Good day, viewers. My name is Miss Aces. Welcome to our 5th program for Geography Grade 8 learners. Today we will learn about astronomical geography, focusing on the lunar and solar eclipses. At the end of today's lesson, you should be able to explain the occurrence of lunar and solar eclipses. Let's begin with our lesson. The lunar and solar eclipses. We have 4 seasons in a year, namely summer, spring, autumn, and winter. They occur as a result of various interrelated factors, such as number 1, the revolution of the earth around the sun, number 2, the tilting of the earth's axis, number 3, the constant parallelism of the Earth's axis. Number 4, the spherical shape of the Earth. Number 5, the rotation of the Earth around its own axis. The December solstice appears between summer and winter. On 21st to 22nd December, the perpendicular rays of the sun fall on the Tropic of Capricorn, which is 23.5 degrees south. Due to the tilting of the Earth's axis, the southern hemisphere receives more heat from the sun than the northern hemisphere. The southern hemisphere has summer, while the northern hemisphere has winter. The southern hemisphere will have long days and short nights, while the northern hemisphere, the days are short and the nights are long. On these dates, the days and nights at the equator are of equal length, 12 hours each. The picture below shows on the left-hand side the sun and on the right-hand side the earth as it's tilted. We can clearly see how the southern hemisphere receives more sun than the northern hemisphere, and thus the southern hemisphere is in summer while the northern hemisphere is in winter. Let's take a look at the March equinox. The March equinox appears between autumn and spring. After 21st to 22nd December, the rays of the sun move northwards until they fall directly on the equator on the 20th to the 21st March. The constant parallelism of the Earth's axis, both hemispheres receive the same amount of heat from the sun. It is now autumn in the southern hemisphere and spring in the northern hemisphere. The picture below shows how this looks. On the left hand side shows the sun, and on the right hand side shows the earth. The arrows in the middle show how both hemispheres receive the same amount of heat from the sun. Let's move on to the June solstice. The June solstice appears between winter and summer. After 21st to 22nd December, the rays of the sun move northwards until they fall directly on the equator on the 20th to the 21st March. The constant parallelism of the Earth's axis, both hemispheres receive the same amount of heat from the sun. It is now autumn in the southern hemisphere and spring in the northern hemisphere. Next, we look at the September equinox. The September equinox appears between spring and autumn. After 20th to 21st June, the perpendicular rays of the sun move southward until they fall directly on the equator on the 22nd to the 23rd September. Both hemispheres receive the same amount of heat from the sun. It is now spring in the southern hemisphere and autumn in the northern hemisphere, with the length of the day and night equal throughout the world. In conclusion, a short summary would be: the spring equinox, 22nd to 23rd September, the vertical rays of the sun fall directly on the equator. The summer solstice, 21st to 22nd December, the vertical rays of the sun fall at the Tropic of Capricorn, which is 23.5 degrees south. The autumn equinox, 20th to 21st March, the vertical rays of the sun fall at the equator. Last but not least, the winter solstice, 20th to 21st June, the vertical rays of the sun fall on the Tropic of Cancer, 23.5 degrees north. Thank you very much for watching. I hope you have enjoyed today's lesson. Take care until we meet again.